Hey guys, today's flipped lesson is on biconditional statements. Keep in mind that there are guided notes that go along with this, so feel free to pause the video, print those guided notes, and use them as you work. If not, your own sheet of paper will work just as well. So, let's start with talking about the definition of perpendicular lines. Two lines are perpendicular if they intersect to form a right angle. So inside of this diagram, I know that line N is perpendicular to line M. Okay, now one thing that I want to mention to add on to this is that all definitions work in both directions, meaning that they can be interpreted both forwards and backwards. Thus, the converse of the statement is always true. So the first thing I'm going to do is I'm going to write this as a conditional statement. So, if two lines are perpendicular, then they intersect to form a right angle. Okay, then we could write the converse of this statement, meaning we're swapping the hypothesis and the conclusion. Here is the hypothesis, here is the conclusion. So my converse would read as if two lines intersect to form a right angle, then they are perpendicular. Okay? Keep in mind that I don't want to use they in the first part of my sentence. You want to talk about what they is referring to. So notice that I always use they or the pronoun in the second part of the statement. Okay, so again, all definitions work in both directions, meaning that they can be interpreted both forwards and backwards, and both would be true in a definition. Okay, now that leads us into what a biconditional statement is. A biconditional statement, is a statement that contains the phrase, so sorry, this word is a statement that contains the phrase if and only if. Writing a biconditional statement is equivalent to writing a conditional statement and its converse. So essentially, guys, biconditional, right? Bi, think to. Biconditional statements indicate that the argument works in both directions. Both directions, both forwards and backwards, which is why we say that the conditional statement and the converse, it's similar to writing both of those. Okay, so statements are biconditional if they work in both directions. So if the conditional is true and the converse is true, then a statement is biconditional. So let's take a look at another definition. Two or more points are collinear if they lie on the same line. So in this example, we have lots of collinear points. There are a few different options. We could say A, X, and C are collinear. Or we could say D, X, and B are collinear in this diagram, okay? So first, let's turn this definition into a conditional statement. So if two or more points are collinear, then they lie on the same line. Okay, then the converse of this statement, we will be swapping the argument. So if two or more lie on the same line, then they are collinear. Okay, now let's assess the truth value of both of these statements. For the conditional statement is true, right? By definition, this is true. The converse of the statement is also true by definition. So, if the argument works in both directions, then the statement is biconditional. So we can write it as this. 2 or more points are collinear if and only if they lie on the same line. So notice, this is not an if-then statement. We've turned it into a biconditional statement where we use the word if and only if in the middle. Now, one other thing I will write off to the side is you can write IFF as like shorthand notation. So instead of saying if and only if, you could put IFF, and IFF stands for if and only if. Okay? Now, let's look at another example. Okay, the definition of coplanar lines. 2 or more lines are coplanar if they lie on the same plane. So you'll notice in this diagram, we have an example of coplanar lines. So first, let's write the conditional for this statement. Okay, the conditional is if 2 or more lines are coplanar, then they lie in the same plane. Then we can swap this argument. We can write the converse. So if 2 or more lines lie in the same plane, then they are coplanar. Okay, now if we think about the truth value of these statements, this one is true by definition. This one is true by definition. Therefore, this argument is biconditional, meaning that it works in both directions. So we can write this statement as 2 or more lines are coplanar if and only if, notice I use shorthand notation, if and only if they lie in the same plane. Okay? All right, let's continue on with another example. We're going to analyze this biconditional statement. Consider the following statement. X equals 3 if and only if x squared equals 9. The first question is this a biconditional statement? And yes, it is. Notice how it's written with the if and only if. Biconditional statements are written in this format. Okay, now let's assess, is this statement true? Well, if x equals 3, does that mean that x squared equals 9? Now, in this direction, yes, it is true. But remember, biconditional means the argument works in both directions. So with this direction, yeah, that direction is true. But what about if we swap it? So if x squared equals 9, does that mean that x equals 3? If we swap the argument. And that would be false. This is not true. My counter example would be x equals -3. So the statement is not true. No. The reason why is that the argument does not work in both directions. When you swap the argument, it is not true, and I came up with a counterexample to indicate that it is not true. All right, last example for the video. Let's take a look. Each of the following statements is true. Write the converse of each statement and decide whether the converse is true or false. If the converse is true, combine it with the original statement to form a true biconditional statement. If the converse is false, state a counterexample. So I'm only going to have time to do one example in this video, so I'm going to work with example B, okay? The conditional says that if a number ends in 0, then the number is divisible by 5. So let's write the converse of that. If a number is divisible by 5, then it ends in 0. Okay, now we're going to assess the truth value of both of these statements. First, let's assess the truth value of the conditional statement. Is this true or false? If a number ends in 0, then it's divisible by 5. I think that this statement is true. Oops. I didn't mean to grab that. I think that this statement is true. Okay, I cannot think of a single number that ends in 0 that's not divisible by 5. I cannot think of a counter example. Now let's take a look at this example. Is this true or is this false? If a number is divisible by 5, doesn't mean that it ends in a 0. I think that this statement is false. And my counter example is the number 25. Okay, 25 is divisible by 5, but it doesn't end in a 0. Now this is one of lots of counter examples that we could write, okay, but statement B is not true. So, or the converse is not true. This means that the argument does not work in both directions. Therefore, this argument cannot be written as a biconditional statement. So, again, if the converse is false, just state a counterexample. You cannot write this statement as a biconditional because the argument does not work in both directions. All right, guys, that concludes your lesson for today. Go ahead and print off those practice problems, give them a shot, and then check your answers with the answer key. Come to class on Thursday with questions ready to go.